Hey guys, go ahead and try your warm-up. We will go over it in just a minute. All right, so let's look at number 1, find the values. So on this one, you are going to want to use your T-chart. So if you were stuck and you haven't tried number 1, there's your hints. Go ahead and do your T-chart, pause the video, try it again. All right, so you want to get your points here. Okay. All right, so let's look at 1A. So we want to start inside here. And remember, this is an angle. It's the angle that gives us a cosine of radical 2 over 2. So if I look over at my T-chart, remember that cosine is the x, y is the sine. So the one where we have a cosine of radical 2 over 2 is pi over 4. So I actually want to do the sine of pi over 4, which is radical 2 over 2. All right, let's look at B. Now we're looking for the angle that gives us a cosine of 1/2. So that would be pi over 3. So I'm doing the secant of pi over 3. Secant is just the reciprocal of cosine. So the cosine is 1/2. The reciprocal would be 2. All right, let's look at C. An angle that gives us a sine of negative 1/2. So remember, sines are y. So I'm looking here at pi over 6. Since it is a negative, I'm in quadrant 4. So that's going to be negative pi over 6. Okay, and now I want to take the tangent of that. So tangent is y over x. It's going to be 1/2 over radical 3 over 2, which is 1 over radical 3. Since we're in quadrant 4, tangent is negative. If you wanted to rationalize that, it would be negative radical 3 over 3. Okay, and then let's look at D. So here we have an inverse sine of negative radical 3 over 2. So I'm thinking to myself, which angle would give me a sine of radical 3 over 2? Since sine is the y, that would be pi over 3. Since it's a negative, it means quadrant 4. And now I want the cotangent of that. So cotangent is, instead of y over x, it's x over y. So this would give me 1/2 over radical 3 over 2, which is, again, 1 over radical 3. Since I'm in quadrant 4, it's a negative. And again, if I wanted to rationalize it, it would be negative radical 3 over 3. All right, number 2, find the angles. Okay, so here we have which angle gives us a tangent of 1. So I'm looking up at my T-chart, and I'm thinking, if I was going to do y divided by x, which of those pairs, when I divide them, would give me an answer of 1? And clearly the answer would be pi over 4. Okay, let's look at B. I'm looking at which angle would give me a sine of negative 1 over radical 2. Well, keep in mind, if I rationalized negative 1 over radical 2, I would get negative radical 2 over 2. So now I'm clearly looking at pi over 4, but since my answer is a negative radical 2 over 2, it needs to be in quadrant 4, so negative pi over 4. All right, next one, C. I have an inverse secant of negative 2. So let's keep in mind, secant is just the reciprocal of sine, or cosine, sorry. So I can actually rewrite this as the cosine and then do the reciprocal, so negative 1/2. Okay, so I did the reciprocal of the secant, which is cosine, and then I did the reciprocal of the answer, which is negative 1/2. All right, so now I look up here. Cosine is my x value, so this is going to be pi over 3. Since this is negative, and this is where we're going to get some people in trouble, pi over 3, I can't just make it a negative pi over 3. Negative pi over 3 is in quadrant 4, and cosine is still positive in quadrant 4. Okay, remember, all students take calculus. So just going negative is not going to give me the right answer here. So I actually want pi over 3, and to make it a negative cosine, I want it in quadrant 2. Okay, so this would give me 2 pi over 3. All right, last one, D. We have cotangent inverse of negative 1 over radical 3. Let's do the same trick that we just did on C. So we're going to change cotangent into tangent, and we're going to do the reciprocal of negative 1 over radical 3, and that's just negative radical 3. Okay, so now I'm looking up at my chart, and I'm trying to find which pair of numbers, if I did the y divided by the x, would I get radical 3. And that to me is looking like pi over 3 because the 2's are going to cancel, and I'm just going to get a radical 3. So this is going to be pi over 3, but since I want it to be negative, that's quadrant 4, so negative pi over 3. All right, let's go down to number 3. Find the derivatives of the inverse trig functions using the formula. So I actually gave you the formulas. You don't have to look back or anything. So we're really just plugging in the values here. These are formulas. We're just going to plug in the values. So let's look at A. So it says inverse cosine of x squared. I'm noticing here that my u is x squared. So what that means is when I go to do my derivative, I'm going to be plugging in x squared wherever there's a u. All right, so I would get negative 1 over radical 1 minus x to the 4th. Okay, and then that is followed up by du dx. That means the derivative of u. So remember, my u in this one was x squared, so I need to times this by 2x. You can add a plus c at the end as well. Oh no, we're not doing integrals. Never mind. Don't add that. Okay, so there we go. All right, let's try B. So on B, my u is the natural log of x, and I'm plugging that in here wherever I see a u. Okay, so let's see here. dy dx equals 1 over 1 plus natural log of x squared, and then I want to follow it up with the derivative of my u, so 1 over x. All right, last one, C. Here's my u, secant inverse, there it is. Okay, so dy dx equals 1 over the absolute value of 2s plus 1 times radical 2s plus 1 squared minus 1. And then all of that is multiplied by the derivative of u, which in this case is just 2. All right, today we are doing the fundamental theorem of calculus. So we're going to read through the fundamental theorem of calculus. It says if f is continuous on a closed interval a to b, then capital F of x is equal to the integral from a to x of f of t dt is continuous on a to b and differentiable on a to b, and its derivative is, so the derivative of the function is basically the integral of the derivative. Okay, so this is a little bit theoretical, a little wordy, a little bit confusing. And the good news for us is we're actually going to skip number 1. I did this last year. It doesn't have a lot of applications in terms of actual problems that we can do, and it's just a little bit confusing. So we're actually going to skip it. Okay, and that means also on your homework that you are going to be skipping 6, 7, and 8 as well. Okay. All right, so let's go back to the second part here, fundamental theorem of calculus part 2. And what this says is that when you have a definite integral from a to b, you're going to do the integral, you're going to plug in the b, you're going to plug in the a, and you're going to subtract them. And that's going to give you an actual number, like a constant for your answer. So that's what we're going to focus on today, is doing some examples just like that. Okay, so let's try example 2. And the integral part is exactly the same as what we've already been doing. Today we're just adding on the bounds, the lower bound and the upper bound. Okay, so let's look at A. So we're going to do the integral of cosine x dx. So what I want you to think is, if I took the derivative of something and the answer was cosine x, what did I really take the derivative of? Okay, so this one's pretty easy. You should be thinking that the answer would be sine, because if we take the derivative of sine, we get cosine. And so here's where it gets a little bit different, a little bit new today. So we're going to now do something with these bounds, the 0 and the pi. So what we do is we put this little line at the end, we put the 0 on the bottom, we put the pi on the top. And so our final answer is going to be plugging in the pi. So you want to plug in the top one first, and then minus the plugging in the bottom one. All right, so now we just need to evaluate this. Okay, so the sine of pi, that's actually 0. The sine of 0 is also 0, so my answer is 0. So I just want to really quick show you guys kind of why this is what's going on here, what we're doing. So remember, back when we did Riemann sums, lesson 4.2, remember, when you're doing an integral, you're finding the area under the curve. Okay, so I just really quickly, I want to show you this. So we have cosine of x. That was our original problem, right? So here's cosine of x. It starts up at 1. Here's pi. It goes down to -1, okay? So this part of this area right here is positive. This part of this area here is negative. They're exactly the same. So when you add them together, they cancel and you get 0, okay? So that's just a little explanation of kind of what we're doing, why it works out the way that it does. All right, let's look at B. So on B, we're doing the integral of secant tan, and hopefully by now we've done this enough times that you're thinking to yourself, okay, I think I know this one. If I did the derivative of secant, I would get secant tan, right? And so on this one, that's our answer, and our two bounds are -pi/4 and 0. Okay, so we're going to plug in 0 first. Secant of 0 minus secant of -pi/4. Okay, so this is actually a good one for our t-chart. I'm going to flip back to my t-chart once you've got that written down. So we have the secant of 0. Okay, so secant of 0. Remember, secant is just the inverse of cosine. So if I'm looking at 0, my cosine would be 1, so the inverse of that would be 1. Okay, minus, and then I have the secant of -pi/4. Okay, so let's look at that. Secant of pi/4, okay, here's the cosine of pi/4, and then the secant would just be the reciprocal of it. Okay, so 2 over radical 2. Now, let's think about the fact that it's a -pi/4. That just means I'm in quadrant 4. But remember, secant is the reciprocal of cosine. Cosine is positive in quadrant 4, so this is still positive. So we are just minusing it. Okay? All right, I'm just going to rewrite this. If I were to rationalize that, it's just radical 2. And I'm going to leave my answer right like that instead of making it some crazy decimal by typing it into my calculator. All right, let's go to C. Let's try rewriting this first. So we have 3/2 x to the 1/2 minus 4x to the -2. This just makes it easier for me to do my integral. Okay, so here we go. We're going to do our integral. Remember what we do. We add 1 to the exponent. So here I'm going to do 3/2 x to the 3/2. We then times by the reciprocal or divide by that, whichever way you want to look at it. So that would be 2/3 minus 4x, add 1 to the -2, -1, divide by -1. Okay, this is being evaluated from 1 to 4. All right, here at the front, the 3/2 and the 2/3 cancel. Here, the negative cancels. That becomes a plus. So I have x to the 3/2 plus 4x evaluated from 1 to 4. Okay, so remember we start by plugging in the 4. That's our upper bound. Okay, I plug that in. Minus, and now I plug in the 1. Notice both of those were minuses because I'm minusing the whole thing. Okay, 4 to the 3 halves. Square root of 4 is 2. 2 to the 3rd is 8. Plus 16 minus 1 minus 4. So this would give me 24 minus 5, which is 19. Okay, wait, I made a mistake. You probably already caught it. You're probably waiting for me to catch it. This was a -1. So this should have been over x. So this would have been divided by 4. That one divided by 1. So this becomes a 1. Okay, so 8 plus 1 is 9. 9 minus 1 is 8. 8 minus 4 is 4. Sorry about that. Okay, let's go to letter D. I'm going to erase this, so just go ahead and pause it if you're still writing anything down. All right, letter D. So let's see here. We have the integral from 0 to 1 of dx over x plus 1. Okay, I don't think we've seen one like this, so I just want to rewrite it for you. This would be the same as 1 over x plus 1 dx. Okay, so what they do is they do write it in a little bit more of a compact form like this, but I don't want it to confuse you because it really is still just the 1 over that and then the dx at the end. All right, so let's take a peek at this one. So notice that I have 1 over, and then on the bottom I have a first power of x. Whenever you have a first power of x on the denominator, that's going to be natural log. Okay, so this one is actually the natural log of x plus 1. And we're going to evaluate it from 0 to 1. People overuse the natural log, okay? So just because it's a fraction does not always mean that it's natural log. This one is natural log because the power of the x in the denominator is 1. Okay, so if you just peek at E, that one's not going to be natural log. Notice it's an x squared, okay? All right, so now we're just going to evaluate this. So we have natural log of 1 plus 1, which is 2, minus natural log of 0 plus 1, which is 1. So this is the natural log of 2 minus natural log of 1 is 0. So my final answer is natural log of 2. All right, last one, E. Let's rewrite it just for your own sake. You don't have to rewrite it, but I do think it helps kind of visualize everything a little bit better. So if you're looking at this one, I don't know, maybe you're starting to recognize some of these. Hopefully you are. This is actually one of your inverse trig functions, okay? So like I said, hopefully these are starting to look a little bit familiar and they're peeking into your mind when you see them. So if you look here, it's one of these, and you're hopefully noticing that it would be inverse tan, okay? So this gives me inverse tan of x, and we're evaluating it from 0 to 1. So we're going to plug in the 1 first, inverse tan of 1, minus inverse tan of 0. This is another great chance for me to use my t-chart. So let's look back. First one was inverse tan of 1. So I'm looking at which angle would give me a tangent of 1. Remember, tangent is y over x. So I want the x and the y to be the same, which would be pi over 4. Okay, now I want tan of 0. So tan of 0, y divided by x. Which xy pair, if I did y divided by x, would I get 0? And that would be 0. So my answer here is pi over 4. When you have examples like this, I am aware that you could have typed stuff into your calculator. You would not have gotten a nice answer like pi over 4. You would have gotten a decimal. So you do need to have the correct answer. I don't want crazy decimals. I'd rather have, like on B, 1 minus radical 2. Or like on D, natural log of 2. Than have crazy decimals, okay? So just keep that in mind. Homework, remember we crossed off 6, 7, and 8. So you are just doing 1 through 5, which is working out the integral and then plugging in the values to evaluate it. One little quick hint for you on number 4 and probably also number 5. On number 4, why don't you try distributing that out? Okay, you can't take the integral as is. And number 5, V for victory, turn that into 2 fractions, reduce them. Okay, those are my tips and my hints to you. Also, number 1, distribute the x. All right, good luck, guys. I'm sure I'll be talking to you guys soon, and take care.